In this video, I want to talk about the applications of a pulse generator and how you can use that to determine the length of a cable. So here we have the sub 1 nanosecond pulse generator based on the Jim Williams avalanche pulse generator. And the output of that is split into a T here, where one side goes into the 50 ohm input of the oscilloscope, and the other side is connected to what we have under test. So I have this piece of RG58U coaxial cable, which has a characteristic impedance of 50 ohms. And so we'll see what happens when we plug this into the T. So what we're seeing now is the original pulse plus reflection of the pulse right here that's at a lower magnitude. And if we take the cursor here, we can measure the time that it takes for this pulse to happen. And it looks like that time delay is about 25 nanoseconds. And so what's happening here is that the pulse is being sent into this cable, and it's traveling all the way across the length of the cable, and the end of the cable is unterminated, and so it's going to get to that point, see an impedance mismatch, and then be reflected back. And so that time delay tells us how long it takes that signal to reach the end of the cable and then go back. So it would be related to twice the length of this cable. So if you didn't know where the break in the cable was, you can use a setup like this, and if you know the velocity that a wave travels through this cable, you can then figure out where that break is.